All right, so here we are today. It should be 5:12 when we're looking at this, okay? May 12th. Here's your warm-up, so go ahead and hit pause, and in a few seconds I'll put up the solution. All right, so in number 1, I needed to solve the equation, but I could only go from negative 180 degrees to positive 720 degrees. So, you'll see my screw up when I get to number 2, but I'll fix it. Anyway, so those are degree measures. So over here it said the cosine of the angle had to equal 1. The only time the cosine equals 1, that's the x-coordinate, is right here on this side of the x-axis. And so I took the first line and I went to negative 180 degrees. And I got it at 0, okay? I was at equal to 1 at 0, so I put 0 degrees. But nowhere in here did I come back and reach that x-axis. So then I started heading towards 720, the other direction, positive direction. So again, I got it at 0, and I went around the circle 360 degrees. Whoop, there you go. I got back to 1 at 360 degrees. And I kept going until I reached 720. And the only other time I intersected that cosine equaling 1 was at 720 degrees. So I listed all of those. So I know my diagrams look a little funny as they're finished. They might have made them a little bit more sense as I was creating them. The sine of the angle equals the negative square root of 2 over 2. Well, I know that that's a 45 degrees thing. I just know that. So, and I want the sine, which is the y-coordinate, to be negative. Well, the sine, the y-coordinate, is negative in quadrants 3 and 4. So I'm doing 45 degrees off of this axis and 45 degrees off of this axis. So when I head to negative 180, I hit it right here when I went negative 45 degrees. And then I hit that value again right here at negative 135. And so I've exhausted that because I didn't hit anything more to 180. So now I'm going to go the positive direction. So as I go around the positive direction, the first time I hit it when I got to 225 degrees, and I hit it the second one when I got to 315 degrees. But that was only the first 360 degrees. I got to go again because I'm heading to 720. So I hit it again here at 585. And then the last time I hit it is at 675. Okay, the mistake I made down here is, I told you before, my brain works in degrees. I wasn't really taught radians, so it's not what's ingrained in me. But I can translate these back to radians really easy once I'm finished. But this says that the sine of the angle is equal to 1. Well, the sine again is the y-coordinate, and the only place it's equal to 1 is up here on this y-axis. And I had to go from negative pi to positive pi, and I did that in my head as negative 180 to positive 180. So I went to negative 180. I didn't hit that axis at all. When I was heading to positive 180, I hit it one time up at 90 degrees. But we know that that's equal to pi over 2. So that's actually what I should have written as my answer. All right, and now this was giving me a couple different things going on. I had to get the sine of the angle by itself to be able to figure it out. So I subtracted 3 from both sides first, and then I divided by 2. And then it was a little easier to understand that I was looking for when the sine of the angle was equal to negative 1/2. So I found out that that is 30 degrees. And in order for the sine to be negative, we need to be in the 3rd and the 4th quadrants, just like we did in this one up here. So I wanted to go 30 degrees off this x-axis and then 150 degrees. So those are all both negatives. That's when I hit those two. And that was 30 degrees before the negative 180. And then when I tried to go the positive side, I didn't hit any of them. So I'm going to go ahead and translate that into negative pi over 6. And what is that? That's negative 5 pi over 6. There you go. Okay. So what we're working on today is we're actually going to be looking at specific trig identities so that we can solve equations using that unit circle. So this is where we're going to pick up. You might want to have your formula packet out because you'll be able to see which ones are included in your formula packet and which ones are not. All right. So the first thing we're going to start with is this idea. We have the sine of 2x equaling the square root of 2 over 2, and we want to do that between 0 and 360 degrees. This is basically the same thing I just did. The difference here is what I want to do is I kind of want to disregard this 2x for a little bit, and let's just call it the sine of a. We're going to make a equal 2x. And that way, when I find out the angle measures, okay, all I'm going to have to do is divide them by 2 to get back to what x equals. Okay, so we're going to look at where the sine of an angle is equal to the square root of 2 over 2. And I know that that's at my 45s, and because it's positive y value, I know it's going to happen in this quadrant 1 and quadrant 2. So it's going to happen at this spot and this spot, 45 degrees off of this x-axis and 45 degrees before 180, right? All right, and I only have to go around this circle one time. I don't have to go all the way up to like 720, basically. Okay, so what I'm going to do is then do my rotation from 0, and it looks like my first one that I'm going to hit is at 45 degrees. And it looks like the second one I'm going to hit is going to be at 135 degrees. So you might think to yourself right now, oh, I'm done because nothing else fits between 0 and 360. But the thing we have to remember is that we're actually looking for double that amount. So these angles are actually twice as big as what we're actually looking for to be in between 0 and 360. So I'm going to keep going just to make sure. So once I get past 135, I'm here to 360. So I'm going to go 45 degrees past 360. So that's 405 degrees. And then I'm going to go 135 degrees past 360. So that's 495 degrees. And if I go one more time around, that would be at 720. So I went 45 degrees past 720, and that's 765. That should cover everything that I'm looking for. I'm only going to use the ones that fall between 0 and 360. Well, this is what A equals. And we know that A is equal to 2x. So that means that x is equal to half of that amount. All right, so half of 45 is 22.5 degrees. So that's one of our answers because that's between 0 and 360. Half of 135 is 67.5 degrees. Okay, that's still good. Half of 405 is 202.5 degrees. That's still good. And half of 495 is 247.5 degrees. And then half of 765 is 382.5 degrees. So this is not the one we're going to use. We're just going to use the ones that fall between 0 and 360. And that's how we did it, is because what we actually calculated was A, and we wanted half of that amount. The biggest mistake that's made with a problem like that is that people stop right here with the 45 and the 135. They forget that, and they'll do the half of that, but they forget that there might be some more included in that. All right, so let's take a look at another one here. Now, this causes people some issues sometimes. Most people look at this question and they're like, oh my God, there's sine in 2 different places, and I don't know really how to handle that. So what we're actually going to do is we're going to look at this in a different way. I'm going to make A equal the sine of x, just to make my equation a little bit more approachable, a little bit more manageable. So every time I see the sine of x, I'm going to replace it with A. So this becomes 2a squared plus 5a minus 3 equals 0. And all of a sudden, we're not in trigonometryville. We're in quadratic town, okay? So right now we have a quadratic that in order to solve, we need to factor. Some people might not have seen that in that original line, and that's fine. But sometimes think about doing that replacement, that substitution, to make it a little bit more accessible for you. All right, so let's factor by grouping. Let's do this old school. A times c is equal to -6, and b is equal to 5. So two numbers that multiply to -6 and add up to 5 are going to be -1 and +6. So it's 2a squared minus a plus 6a minus 3 equals 0. And then I group by front 2, and I see I've come a factor of a. So that leaves me with 2a minus 1. And I group my last two, and I have a common factor of 3. So that leaves me with 2a minus 1, which is beautiful. Okay, so my first factor is 2a minus 1, and my second factor is a plus 3. Following along with quadratics, the way we'd solve for a is to set each of our factors equal to 0. So 2a minus 1 equals 0, and a plus 3 equals 0. Well, right here in this spot, I want to replace my a with the sign of x. I'm going to put it back in now. So 2 times the sine of x minus 1 equals 0. That's the equation I'm going to solve. And sine of x plus 3 equals 0. And that's an equation I'm going to solve. So what I'm really doing is 2 times the sine of x equals positive 1. So where does the sine of x equal 1/2? Oh, well, that's just like what we've just done. But getting down to that point was not necessarily obvious. This is given in radians. We do have to pay attention to this because if the domain is given in radians, we have to give our answer in radians. And, you know, a lot of times I'm going to screw it up and put it in degrees when it's not supposed to be. But if I'm thinking about the sine being 1/2, I know that that is 30 degrees. And so I want 30 degrees here, and I want 30 degrees here. Okay, so this first 30 degrees is going to be pi over 6. And this is pi over 6, and then 2 pi over 6, and 3 pi over 6, 4 pi over 6. This one is 5 pi over 6. Okay, so those are my two answers for this one. So x equals 5 pi over 6 and pi over 6. Okay, that's the two answers from that factor. Let's see what we get over here with this factor. I'm going to subtract 3 from both sides. So the sine of x equals -3. Well, the value of sine can't be less than -1. So this doesn't give us any solutions here. That's not possible. So these are our only two solutions. Okay, let's try the next problem. So the problem we did the one before last that had that 2x in there. Sometimes we might not be able to handle it the way we did. Sometimes we might need to bring in our double angle identities. And lovely enough, the cosine of a double angle has 3 identities that we could use for it. So basically, if I'm told that the cosine of 2 theta is something, I can actually replace that with 1 minus 2 times the sine of theta, or 2 times cosine squared of theta minus 1, or cosine squared minus sine squared theta, whichever one serves my purpose best. And if I'm told that the sine of the double angle, okay, I can replace that with 2 sine theta cosine theta. And sometimes I'm going to have to work through in my mind which is the best one, especially for this one up here in the top. Which is the best one to use for the problem I'm given? There's not one general rule you can follow. All right, so let's see what we're given. So we are given that the sine of x equals 3/4, and our x is somewhere between 0 and 90 degrees, and we want to find the exact values. Now, it's not going to be hard to find the cosine of that angle. I'm going to show you actually a different way that hopefully will help you out some. Almost there. Give me 1 second. Okay. So a lot of times somebody is given something like that and they automatically do the Pythagorean identity. I kind of cheat a little bit and I use what I know about right triangle trig. So if the sine of x equals 3/4, I remember from right triangle trig that the sine is the opposite over the hypotenuse. So I give myself a nice little right triangle here, and I say, okay, the opposite then must, and we'll call this x up here, the opposite must be 3, and the hypotenuse must be 4. So if I want to figure out that other side, which comes into play to the cosine, I can do that by using the Pythagorean theorem. So I would say 3 squared plus, let's just call it q, all right, because that's the side we need, squared equals 4 squared. Excuse me. So we've got 9 plus q squared equals 16. So q squared equals 7. So q is equal to the square root of 7. which then I can find the cosine of x equals the adjacent, which is q, over the hypotenuse, which is 4. So that's one way to do it. Now, the way the book shows it, obviously, is going to be with the Pythagorean identity. It's saying that the sine squared of x plus the cosine squared of x equals 1. It's the same basic idea. It's just what we're comfortable with. And I'm more comfortable with the Pythagorean theorem and my right triangle trig. That's all. So they gave me the sine, so I'm going to put 3/4 squared plus cosine squared equals 1. So this is actually 9/16. I'm going to subtract 9/16 from both sides. So that gives me that the cosine squared of x equals 7/16. And then I'm going to take the square root of both sides. So the x is equal to the square root of 7/4. Same result, two different methods, and that's perfectly acceptable. All right, so now what I want to find is, let's go to letter B. I want to find the sine of 2x. Okay, well, I know the sine of x. How am I going to get to the sine of 2x? I also now know the cosine of x. So let me go back and look at my double angle formulas. The only one I have is this one down here for the double angle of sine. So I'm going to write 2 sine x cosine x. That's what it's going to equal. So that equals 2 sine x cosine x. And I can do that no problem because I have those values now. The sine of x was given at 3/4, and the cosine of x is what we found, which is the square root of 7/4. So what I'm getting is 6 times the square root of 7/16, or I could reduce that to 3 square root of 7/8. All right, so let's try letter C now. Letter C we'll put down here. And this says, what about the cosine of 2x? Now, with the double angle for cosine, we actually have a lot of options to pick from. So let's go back and look at those options and see which one might be best. Well, we could use this one here because I know what the sine is. We could use this one here because I know what the cosine is. We could use this one here because I know what they all are. Okay? So it's really my preference at this point, which one I want to use. Why don't we just use the one off the top, 1 minus 2 sine squared x. All right? So that equals 1 minus 2 sine squared of x. So I'm going to put in the sine, which was given. I like to just, the reason I chose that one truthfully is because it only used information that was given. If I had made a mistake on finding the cosine, then it would be some follow-through mess that might not get caught in grading. So if possible, I try to only use given information so I don't mess something up. So I'm putting the sine of x in here, and I still have to square it. So this is going to be 1 minus 2 times 9/16. So this is going to equal 1 minus 18/16. Okay, so that actually is negative 2/16. Simplified would be negative 1/8. Okay, and then the last one I'm going to do, letter D, this is one that's not actually written down. I need the tangent of 2x. It doesn't matter what this angle is in here. The tangent is always equal to the sine of that angle divided by the cosine of that angle. Okay? And we know the sine of 2x and we know the cosine of 2x. So I'm going to put them in. So the sine of 2x is 3 square root of 7/8. And the cosine of 2x is negative 1/8. Okay, so I know how to handle fractions and division. I just copy the first one, change it to multiplication, and I reciprocate the second one. Oh, well, lovely enough, those 8's cancel out. So I think our answer should be just negative 3 times the square root of 7 for the tangent. All right, let's try the next one. Okay, so Kind of cheated. Remember on the last one, I was given the cosine, or I was given the sine, and I found the cosine by using the Pythagorean theorem. You could do that here for letter A as well. Or we could do it the way the book wants us to do it, which is saying that the sine squared plus the cosine squared should equal 1. It's going to work out to the same problem. So I don't know what the sine is, but the cosine is 4/5. So I'm going to square that, and this is going to get me the sine. So the sine squared plus 16/25 equals 1. I'm going to subtract that from both sides. I believe we get 9/25. 9/25, and we'll take the square root of both sides. Okay, so the sine of theta equals 3/25. Now we know this could be positive or negative. What we really need to do is we need to look up here at the domain that they gave us and see which angle they're actually looking for, the positive or the negative. So if I'm looking at 3 pi over 2 to 2 pi, that's looking in this quadrant right here. And in this quadrant, the sign is negative. So I'm going to put a negative sign right on there. Okay? So there's my sign. And now I want to find the cosine of 2 theta. Okay? Well, there, like I said before, there were 3 different things that we could have used to deal with the cosine. I'll go back to that slide real quick. So we could use sine. Well, we know sine, but we figured sine out. So do you trust it? We could use this one. This looks like a good one because cosine was actually a given piece of information. So we'll probably be using this one because this one uses the cosine and the sine. And again, that was something we calculated. So let's go ahead and use this middle one now. That's how I make those decisions. All right, so we're going to use 2 cosine squared theta minus 1. All right, so we know the cosine because it was given as 4/5. And we're going to square that and then subtract 1. So I have to square first. So 16/25. Then I have to multiply by 2. So 32/25. And then I'm going to subtract 1. 25 plus 5, 6, 7. So that's 7/25. That's my answer. The cosine of twice the angle equals 7/25. All right. We'll move on. You can always pause. If you're not done writing something down, feel free to pause. Okay. It's kind of like self-paced here. All right, we want to solve this equation between 0 and 360 degrees. We're not going to use the calculator for this. Okay, so the first thing we see is that the sine of 2x equals the sine of x. That seems a little crazy, but we'll go with it. So let's replace the sine of 2x. Okay, look at your formula packet. There's only one thing we can replace the sine of 2x with. So we're going to go ahead and do that. And that is 2 sine x cosine x equals sine x. All right. At this point, I think what I want to do is bring everything over and set it equal to 0. 2 sine x cosine x minus sine x equals 0. I could have thought about, at first I thought about dividing sine x out of both sides, but the problem with dividing it out is that we would kind of lose it, and we still need it to be a factor. So that's why we don't want to just divide it out and get rid of it here, okay? All right, but what I can do at this point is factor it out. So let's go ahead and factor out the sine x, because that's in both terms. So sine x, and that would be 2 cosine x minus 1, and that equals 0. Okay, so again, it's basically like a quadratic. I have 2 factors, they're equal to 0. So the zero product theorem says that, well, one of these two things has to equal 0. So what would make the sine of x equal 0? And what would make 2 cosine x minus 1 equal 0? And we'll solve both of these. So when does the sine of x equal 0? Well, let's think about that, between 0 and 360 degrees. So the sine is my y-coordinate. So my y-coordinate is right here at 0, at 180, and again at 360. So this one's getting me 0 degrees, 180 degrees, and 360 degrees right off the bat. Okay, now I'll go ahead and solve this one. I'm going to add 1 to both sides. So 2 cosine x equals 1, and the cosine of x equals 1/2. All right, let's think about where the cosine, or the x-coordinate, equals 1/2. And I believe that's going to fall at your 60 degrees is? That sounded funny. So 60 degrees, and it's positive 1/2. So we want 60 degrees here, and I believe we also want 60 degrees here, because that's your x-coordinate, right? So we want 60 degrees down here also. All right, so that tells me 60 degrees and 300 degrees. So I think I have 1, 2, 3, 4, 5. Yeah, I have 5 answers. I have to keep all of those answers. Those are all together. 3 of them came from the first factor, and 2 of them came from the last factor. Now, if I had taken out that sine x, this problem, I would have lost those 3 angle measures. So keep that in mind, that you shouldn't just divide out a variable and get rid of it when you're solving. Try and pull it all over to one side, and it will work a lot better for you. So I think that's it for today, except for the closure. Okay, so here is your closure. Go ahead and do that. And it's on as an assignment, so I want to see your work. You can either write directly on the Word document I have there, or just write on paper and take a picture. Okay, till next time.